Hey, I'm Chris Ralph, the professional prospector, and today we're going to be talking about how to assay test for free gold. Now, I get people all the time want me to send pictures of their, or want to send to me pictures of their rocks and to try and figure out, do their rocks have any gold in them? And what I tell people a lot of times is you just can't look at a picture and just know magically how much gold is in there. So I'm going to talk to you about how to test rocks. You want to test a rock? You think you might have gold? Okay, good. That's great. Let's test it and see how much free gold is in it. And that's what we're going to talk about today. We're basically going to do our own little home scale assay to test and see how much gold you have in your rock. Basically, we're going to go through some samples, but the process, just as a general thing, says the first step is to crush the rock down to a free sand, or a small sand kind of size, a fine sand, not like pea gravel or something like that, but down to fine sand. And that's difficult, but I'll show you how I do it, and we'll go through the process. And then concentrate the rock. Even rich gold ore has just a small amount of gold compared to the amount of rock. I mean, rich gold ore has an ounce of gold per ton, but it's an ounce of gold, 1 ounce per ton, 2,000 pounds of rock. So you got to concentrate it. And panning, if you have a small sample, or other means, if you have larger samples, we'll talk about those in a bit. And then weigh out the gold. See how much gold you have. You have to weigh out the sample first. I should have said that up here. Before you crush it, weigh the sample, see how much you got, okay? And then at the end, you weigh the gold, see how much gold you got, and then you calculate the values. So many grams per ton, so many ounces per ton. And that's what you need to do, you do a little calculation, and I'll go over all that with you. Now, what are we going to do for our little test run here? Because I'm going to demonstrate this to you. Well, I have 3 samples. One, the whole sample is just this single rock. But this piece of quartz vein was from a mining district in Nevada, and I ran my metal detector over it, and it beeps. Now, I've looked at it real closely with a loop even, and magnified, and I don't see any gold on the outside of it. But the metal detector says there's metal on the inside, because it gives not a ferrous or hot rock kind of a response, but it gives a positive conductive metal gold type of a response. So and I've found pieces like this before that don't show any gold on the outside, but have some on the inside. We're going to crush this down. I've weighed this. This thing weighs about 2 pounds, but when we do our calculations, we'll have an exact number. Then I have about 20 pounds, more or less, I'm going to weigh it up, of this kind of rock, which is quartz with oxidized pyrite. And in other words, it's pyrite that's been close to the surface for so long that it's basically converted from pyrite to rust. And we're going to crush this up and see what gold we get out of it. There's actually a few little pieces in this mix of the 20 pounds that actually have a little bit of visible gold in it. So we're going to see what we get out of that. That's about 20 pounds of that, but I'll weigh it up and get an exact number. And then I have roughly 50 pounds of another sample that I think, based on some old other assays that I have, I think runs around 1/2 to 3/4 of an ounce per ton, but I have 50 pounds of it. And so we're going to get a good accurate thing. One of the things that I want to talk to you about when you're doing an assay for free gold, don't just have a single piece like this, that weighs an ounce or 2 maybe. When you're doing assays this way, you really want to have a larger amount. You want to have a good amount, because the problem is, if you have just one rock like this, remember the one that I said that the metal detector beeped on? Well, this is going to give an unusually high number because we know there's enough gold in it to make the metal detector beep. So we're going to get a high number. And it was that rock was in a pile of quartz, which I tested all the quartz. That was the only piece that beeped. The rest of them, you know, no beeps. So, you know, having a large sample gives you a more accurate, more reflective type of result that tells you really, you know, what do you have in this rock. You could be sampling old mine dumps or a vein someplace or something like that. You want to have a good number for the average typical amount of gold in that rock, and that makes perfect sense, you know. So we're going to go through that. So that having been said, and just giving you an overview and an introduction to this little project, let's go out and break some rocks. Okay, so I've weighed up the different samples that I got. The single piece, which is this one, weighed 2.11 pounds or 960 grams. Okay, and then the stuff I got up at Virginia City, which is this material, came out to a total of 26.6 pounds. And then the other thing, which I'll show you in a bit, is from further out east in Nevada. It weighed 58.4 pounds. So, like I said at the beginning of this video, one of the things about doing your own assay and being able to weigh it and have decent results is having a large sample size. You know, in assay labs, they do, you know, just little tiny bits, you know, an ounce or two of rock, and you know, it reflects what's in that ounce or so, but that may or may not reflect what's in a whole vein or something. So what I do have, and I wanted to show you, is I've got some rocks here that are basically just too big to go into my little jaw crusher, and I've got to take my little flat piece of steel and a hammer and bust them up. So I'm gonna do a little bit of that right now. I'm gonna start with doing that, and anyway, I'll get this done and then I'll show you. The next step is to, because these pieces are too large for the jaw crusher, so the next step is to then take all the material and run it through the jaw crusher. That gets it down to around minus half or 3/4 of an inch, which is nowhere near large enough to do your final panning or sluicing and gold extraction. But the hammer mill that I have, if you put in minus half or 3/4, that kind of stuff runs great. You put in big chunks and they just bang around in there. Anyway, works way better with the jaw crusher first. So I'm gonna hammer these rocks. It makes a lot of noise, so I'm not gonna put you through that. In the next step, I'll show you the jaw crusher. All right, so I'm in my garage and I'm crushing up the rock. I'm taking the stuff that I broke yesterday and the pieces that were small enough to go into the jaw crusher. You can see my jaw crusher isn't very big. And you know, I have a motor for this. I just have to clean up all this junk and get the motor installed and operational. But to save time, I'm gonna just run through and crush it by hand. The jaw crusher works pretty good. These jaw crushers of this type have been around since the 1800s. They used to use them in front of the stamp mills. So the rock came in, went through a jaw crusher, and then into the stamp. And of course, this is a tiny, tiny jaw crusher. They make ones where the opening is, you know, a couple feet across, or even bigger, 3 feet. I've seen ones as big as 3 feet across, and they make them even larger. But this is a little tiny guy, and I'll be using it to break my rock down to usable size. And it's not really an exciting process to watch, but I thought I'd give you the feel for it. You can probably see it coming out down there below. Goes into this bucket. I'll collect it up. And then the next step will be the hammer mill, and I'll show you the hammer mill right now. So I didn't even try to talk over this. The noise from the mill was so loud, you know, you wouldn't have been able to hear me clearly anyway. So I thought I'd just do a narration over the top of it. And that way, you know, you could see what I'm doing and I could tell you a little bit more about it. The round chain mill has 4 sets of chains that spin around there from a motor at a really high rate. And then that just smashes the pieces because the chains are spinning so fast. It just smashes the ground up ore to bits. And then at the bottom, we have material sucked out, and that's been fully crushed because it passes through a screen. I have to feed it in slowly because if you feed it in too fast, it just fills up and the screen gets blinded. And then what happens is the chains slow down because they're beating against the pile of ore that's in there, and then it trips the breaker, and so it's a big mess. So you really don't want to load it in too fast, just a little at a time. That's why you see me being super careful. I've got that red feeder thing that I made because normally it's just a square tube that's vertical on this chain mill. So I welded up a feed, basically a feed slot, so that I could feed the material in more carefully. And the other thing is the chain mill will shoot stuff up the top of the tube there, and so having a top on the tube also helps from material shooting around and everything. So here, let me show you a little bit more detail about how this thing works. A couple of photos will explain how the chain mill works. So here's what the inside of the chain mill looks like. You can see that it's just inside there. The material comes in on the left, that square hole, and then the chains spin around so fast the material gets smashed against the walls of the crusher. Here's a close-up of the chain itself that does the actual crushing. I've welded on a little bar there because there's a lot of wear of the steel as it crushes, and the bar just extends the life of the chain. Here's a close-up of the screen. When the material is smashed small enough, it gets sucked through the holes in this, and it's ready for the next step. Okay, so here I'm out here at a friend's claim, and I'm borrowing his gold cube and using it to process the 2 big samples that I had. And the gold cube works great for getting fine-sized gold, and it's a whole lot faster than panning. And I can just take a scoop or so and slowly feed it into there's a screen here just in case there's any rocks that are too big. Just slowly feed the scoop in, get another scoop, slowly feed that in, and believe me, this is a whole lot faster than panning through, 58 or something like that pounds. I think this sample was 58.4. That's a lot of panning. Let's take a look at a different angle for the gold sluice, the gold cube. This is just a different look at the same setup. You can see the little screen that I feed into, and then each layer of the gold cube is got a different matting or material in it. Okay, so the final step in separating the gold out so we can measure the weight of the gold that was in our samples is to carefully pan it out. And I've got just the single rock sample. Didn't go through the gold cube with just the single rock because it was only a couple of pounds, but I've got a little bit of jet dry in here, and I'm just going to carefully pan this. First thing I'm going to do, of course, is make sure it's all thoroughly wet, that the whole sample there's no dry pockets in here. But then I'm going to very carefully just go through and pan it You know, panning with the intent that I know I'm processing very fine, small gold. This stuff, of course, unlike the stuff that went through the gold cube, this stuff just it has all the quartz and stuff in it, whereas in the stuff that's been through the gold cube, the majority of the quartz has been washed out. Okay. Well, I'm not going to make you watch me go through this whole process because it'll be slow and it'll take time. And that's one of the things about panning really fine gold is you need to take your time and go slow. You know, don't waste it. Don't lose it by panning too fast. Don't splash stuff all around. Just go slow. Wash the stuff off. Shake it down. Wash it off. Okay. Anyway, you get the idea, and I'm going to do the same thing with the samples I ran through the gold cube. Only with them, well, with this one too. I will use a little snuffer bottle to pick the gold out when I get to the end. I'll show you that.
Here's just a look at the gold that I panned out, and this is only part of it, but you see the little yellow rim at the top. That's the little tiny bits of gold. There's more gold in here, and I went through several times to make sure that I got it all, but this is kind of the first pass, so you can see there's a trail of gold up there. Here is that material from the single rock that I metal detected, cleaned all up and gotten down to a nice clean a little pinch of gold there. Now, the chain mill that I use, it does add a lot of iron, and I took that out with a weak magnet because the iron will attract very easily to a magnet, even one that's comparatively weak. And I cleaned all the sulfides. There wasn't much sulfides, but there was some. Cleaned it all up pretty good, and a small amount, but there were a few little coarser pieces in there. It must have been one of those coarser pieces that I was able to metal detect. The coarser piece probably was close to the surface on one of the sides, and that's why I was able to detect it. So let's take a look at it on the scale. So here it is on the scale, and you can see it's 0.116 grams. So a little more than 1/10 of a gram. But for a 2-pound rock, that's a pretty good result. We'll do the numbers in a minute. So here's the clean sample of the quartz-rich ore that I had, the stuff that weighed, it was a bucket full and weighed about 26.6 pounds was the amount of ore. And it had a lot of pyrite and oxidized pyrite limonite in it. And that separated fairly easily. And so I ended up with this clean sample at the bottom. Of course, I used the magnet to remove any steel that was in there. And it looks okay. It looks very similar to the last sample. We'll see here that it's just a hair more than the last sample. So here is the results of that quartz-rich ore. And you can see at 0.13 grams, it's only a little bit more than the last one before it that was 0.116. It's not very good considering the fact that it came from 26.6 pounds of sample rock. Let's take a look at the next one. So here's the results from the last sample. This is a sample of material that is not quartz rich. It has some quartz in it, but not quartz rich, pretty iron rich. And it weighed 58.4 pounds. And I was really hoping that this would come out as a good one. And there's not enough gold there to be as much as I was hoping for. So here's the final sample on the scale, and yeah, it weighs more than any of the other samples at 0.208 or 0.208 grams of gold, but it came from a much larger sample. I mean, the quartz rich was 26.6 pounds. This was 58.4 pounds. So a lot more rock and not producing nearly as much gold as I'd hoped for. And there's a reason for that. Here is a picture of that iron-rich ore from Nevada that I have. And the reason I was really hoping it would turn out much better was because I've got quite a bit of it. I've got about 3/4 of a ton of this stashed away, ready to be milled and processed. I was hoping it'd run better than half an ounce, maybe more like 3/4, but I don't think the numbers are going to justify that. So let me go to the whiteboard and we'll take a look at the numbers and talk about what they would mean for you as a individual miner, what they mean for me, and what kind of rules of thumb make sense for small scale hard rock mining.
Okay, well, we've gone to the whiteboard to really analyze what our sample results mean. We've gone through the whole process. We've collected the samples that we wanted to know what they ran. We've gone through the crushing and processing. Two of the samples I did on the gold cube. One of the samples was small enough that I could just pan it out by hand. And now it's time to take all those numbers that we measured, do a little math and see where we're at, and then talk about what that all really means. So my first sample was a single rock that weighed 2.1 pounds, and it was metal detected in an old gold district. It gave off a very weak signal, but it did have a signal, okay? And the single rock, 2.1 pounds, is 1/952 of a ton. So in other words, 952 times 2.1 pounds equals 2,000 pounds. Okay? And so 952 times 0.116, that's what the gold from that rock weighed, gives you 110 grams per ton of rock. And 110 grams divided by 31.1, which is grams per ton, gives you 3.5 ounces per ton. That's a really good result, 3.5 ounces per ton. In fact, if I ever go back to that district, because it's some hours drive away from my house, if I ever go back there, I'm gonna be sure to bucket up and take some more of that rock home, because 3.5 ounces per ton, that's worth going after. Now my sample number 2, it was some quartz rich rock that had a lot of pyrite, both fresh and also altered and turned to rust, turned to limonite by weathering. But that sample weighed 26.6 pounds, and 2,000 divided by 26.6 gives you 75.2. That's the number, that 75.2 times 26.6 will give you 2,000 pounds a ton. And so 75.2 times the 0.13 grams that the gold from that sample weighed gives me 0.98 grams, 9.8 grams. 9.8 grams divided by 31.1, it gives you 0.32 ounces of gold per ton of rock. Not nearly as good as the 3.5 ounces per ton, because the 3.5 ounces per ton, I mean, at $2,000 an ounce as it is today, that's really good rock. I mean, 2,000, that's $7,000 worth of gold. Pretty impressive. But like I say, I only had one 2-pound sample of that. This stuff, I didn't have access to that much more of it than the 26 pounds, and I was kind of disappointed by the 0.32, but that's why you take samples. If you just assume something's rich and then you spend a lot of time and effort processing it, you could be really disappointed. So I processed a smaller amount, got the numbers I need to know, and now I know what that rock kind of runs. About 1/3 of an ounce per ton. All right. Now the last sample was this iron rich rock, and I showed you a second ago a picture of that. And I've collected, it was from an old custom ore processing mill that ran in Nevada back in the 20s and 30s, that they had set some of this rock aside. And I thought, well, they processed so much of it, they kind of spilled a little bit of it around here and there, because it was kind of spread around. And I gathered up a bunch of it, and I ended up with 1,500 pounds, because there was a lot of that rock around. So I thought, dang, I really need to do a sample of that. So I got 58.4, well, almost 60 pounds, and the number where you take 2,000 pounds in a ton divided by 58.4 pounds gives you 34.2. And 34.2 is the number. If you do 34.2 times 58.4, you get 2,000. And so 34.2 times the weight of the gold, 0.208, gives me 7.1 grams per ton. And that divided by ounces gives you 0.23 ounces per ton, which is a little less than 1/4 of an ounce per ton. I was hoping for some number like 0.6, 0.7. and instead I got 0.23. Not really as good. I may still go ahead and process the rock if I get a chance to do it easily. You know, a friend of mine is talking about bringing a mill up here, and you know, I may just gather that stuff up. Better to run it and get 5 or 6 grams of gold out of it than to just leave it sitting as a pile. So yeah, it may be worth it after I've gone ahead to gather it all up. I've already gone through that amount of work. So the question then is, people ask me this regularly, you know, what's a good number? What is okay for an individual guy or a small group of several guys that are working a hard rock prospect and to make it worthwhile? Well, I'll be real honest, it's a lot of work to gather up ore. Especially you have to drill and blast. If you can just take it out with a hammer mill, like a electric or engine powered hammer mill type thing, that you can get it out of the face, you know, it's a lot easier than having to drill and blast and muck up the blasted material and hauling it out of a mine. I don't know if any of you guys have been watching at all Jason at Mount Baker, but he's got a prospect he's working. It's got a really flat vein. Flat veins are way more work than ones that are steep enough to have gravity bring the material down for you. And he collected a bunch of material back in the mine, but he estimated that he had to handle it 10 times to get it out the portal and onto a truck to haul to his mill. That's a lot of handling. And so, you know, normally I tell people half an ounce is the bare bones minimum. If it doesn't run half an ounce, it's really not worth your time as an individual or a small group. And he's probably got stuff that runs half ounce or a little bit better. You have to handle it 10 times, you know, push it down a drift and then drop it down a raise, and then push it down another drift and drop it down another raise, and do back and forth and haul and do and you know, carry it out and then carry it onto your truck. That's a lot of work. And so the amount of work that you have to do does make a difference in what is worthwhile. But for me, I would say half ounce is really the bare bones worthwhile. You guys may have other opinions. If you have another opinion about what's worthwhile, hey, put it down in the comments and we'll talk about it. And you know, if it's easier to get the rock, if you can just pick it up like I did with this stuff, it was at an old mill site, I just picked it up. It's not as hard as having to, you know, mine it in the back of a mine and handle it 10 times to get it out to your truck, you know, at the end of the road. So how much work it is to gather it and get it collected, you can mine it, makes a big difference. But my rule of thumb is half ounce. If it's more work and more effort and harder, it may need to be more than half an ounce. And if it's super easy, you can just kind of scrape it all up. There's a big pile of it, just shovel it into buckets. Well, maybe a quarter an ounce would be worthwhile to process. It just depends, you know, on the price of gold, of course. But right now, it's at about $2,000 a pound, or $2,000 an ounce. I'm sorry, and that's a pretty good price for gold. It's not great, it's not super, but it's good. It's an excellent price. It's certainly near the top of its range. Now, one of the things I do want to say about mining high-grade spots and that kind of stuff is that spottiness is important in gold mines. And very rarely will you find a gold mine with a vein and it's just all great all the way down the vein. You know, you can go 300 feet down the vein and it's just as great at you know, 300 feet away as it is where you start, and it's good every place in between. It just doesn't work like that. It's like streams. Placer streams are the same kind of way. You can go to a gold-rich stream and take 10 samples and they all stink. But if you go to the 10th or the 11th or 12th place, you might get lots of gold. So you have to look in the right place. And the same thing occurs with gold veins. You have to be in the right spot. And some spots may be super rich and other spots may be not so great. And as an individual miner, you're not looking to handle bulk processes where, yeah, I'm going to take out, you know, 500 tons and process it, you know, and haul it out on big haul trucks with front end loaders and there. The big mines that, do heap leaching and other processes, they can handle the hundreds and hundreds of tons. You're looking as a small miner to handle tens of tons, maybe even tens of pounds, maybe even hundreds of pounds, but you're not looking to process hundreds of tons. And so spotty mines are okay for individual prospectors. You just have to find those rich spots. And one of the ways that you can find rich spots is with a sensitive metal detector, which is how I found this first sample up here, which grades 3.5 ounces per ton, which is way better than 1/2 ounce per ton. And like I say, if I could get a substantial amount of rock that graded like this, I would certainly be in for that. Even better, even higher grades. But so as a small miner, remember that, just because you take one sample and it's not very good right where you took the sample, and you might take a few more samples and see. I had a friend who did the same thing. He took a couple of samples and they had good gold, but not, great for him as an individual. And he started sampling around and was able to recognize a part of the vein. And in the part that he was working when I was there, it was the central part of the vein. So in other words, there was a vein, but the core of it was the high grade. And when he mined that core central part, it was pretty high grade. But the sides weren't so good. They had gold, but not so great. So one of the things that the spottiness is to be able to tell where the good gold is and to be able to recognize it. And it takes testing and sampling. And my friend does a lot of testing and sampling. Take a small sample, crush it up, see what it runs. And that's a really important thing. It doesn't always run in the core. I want to say that sometimes it's usually either one of three places, either on the hanging wall, on the foot wall, or in the core. That's where usually your high grade would be. It's not always that way. That's not an ironclad rule, but it's pretty common for it to be one of those three: hanging wall, foot wall, down the middle. I hope you've enjoyed this talk about the home assay sample process and how you can test and find gold and how you can work hard rock gold and make some good gold for yourself. And I hope that it pans out for you and you're able to find some good hard rock ore. Now, finding hard rock ore is a skill. It's a part of prospecting. And if you want to learn more about how to prospect and find your own gold and find those spots that have that good gold, I wrote a book called Fistful of Gold, because that's what I want you to find, is Fistful of Gold. And I'm going to tell you a little bit more about my book right now. So this is my book, Fistful of Gold. You can see it's an encyclopedia distilling down my 45 plus years of prospecting experience plus my degree into the parts that you need to know. I spent most of 10 years writing this. It was not just a simple effort that, I sat down and wrote it. You can see it's like 250,000 words. It's not something you're going to read through in a day or maybe even a week or more. But it's got a lot of information and reference material that you can come back to. You can read it once and read it again and get more out of it, because there's just that much depth of material in this. I wrote this book because I want you to have the skills to go out and find fistfuls of gold for yourself. And if you have the skills and know what you're doing and get out in the field and make a real effort, you can find significant gold. It's not easy. I'm not going to tell you that, because, gold, it wouldn't be, close to $2,000 an ounce, which is what it is right now. It wouldn't be so expensive if it was easy to find. It's not easy. You just can't walk out into an old gold field and start picking up nuggets. If the gold was easy to see and find, the old timers would have picked it up and taken it themselves. So you got to have skill. You got to know what you're doing. You got to be able to master what it takes to find gold, and you've got to have the persistence and put in the effort to find the material, to find the gold or diamonds or gemstones that you're looking for. Now, this book has geology, it has facts about gold, it has stuff about diamonds and platinum, but it's mostly about gold deposits, how gold deposits form, how placer and nuggets form,
all the questions you've probably wanted to ask. The book is available on Amazon, and I'll put a link to it in the description below, but you can look up on Amazon Fistful of Gold and by Chris Ralph and find this book. Now, the book, if you look on it, it has a very high rating. It has like a 4.7 or 4.8 out of 5, which is really high. I mean, it's hard to please everybody, but I'm close to a 5 out of 5, not far from it, right? So it's been out. I've sold more than 15,000 copies of this book, and I've had tremendous response, tremendous positive response by the people who buy it. And I think if you buy it, you'll be just as happy with it. Now, in addition to my book, I also have a website that I do, and I'll tell you a little bit more about my website and show you some images from the website right now.
Now, my website is nevadaoutbackgems.com, and I'll put a link to the prospecting page, this prospecting encyclopedia page, down in the description below, but you can find it at Nevada Outback Gems. I sell some jewelry, turquoise, other gemstones there. I don't always keep the inventory perfectly up to date, so if you're interested in anything you see, do contact me first before trying to send me money or anything, because I want you to be able to get what you order. But the website has lots of different stories, old adventures, even some stories, true stories from the old-time miners of the 1800s. So I think it's something you'll find interesting.
The other thing I want to go back to is that all my comments, I want you guys to ask questions on the comments for my videos. I answer 100% of the comments that are made on my videos. Now, sometimes if somebody just says, hey, great video, I really enjoyed it, the comment may just be, well, I'm really glad you liked it. Or if it's a simple question. And sometimes I get people who ask me questions, I would take a book to answer that question. And I recommend that they just buy the book. But I answer all my questions. I try to help people as much as I can. I'm here to help you. So if you're interested in gaining the skills, if you're interested in knowing what you need to know to be successful, follow along with me. Subscribe to my channel, hit the bell so that they'll let you know when I come out with new videos, and I try to do that pretty much every Saturday morning. And you'll enjoy with me, you'll come along with me, we'll have an adventure together, and we will find some nice gold and see what it's really like getting out in the woods, or the deserts, or the mountains, wherever we land, wherever the gold is, wherever the diamonds are, wherever the platinum is. Come along, we'll have some fun. And I'll see you real soon on the next video.